Hello, in this video I will show you how to use the REFramework with all the UiPath queues using the MySQL database. I'll also show the necessary adjustments to make this possible. This is an useful process if the cloud orchestrator is not available and there are robots that need to work with some kind of queue. We'll get the data from this spreadsheet and insert it into our database using the dispatcher. Next, we'll use the performer to insert the values from the columns caching, honest check, and honest check from the database into the UiDemo application. Our dispatcher is a linear process, only having the initialization, process, and end process states. In the initialization state, we write an activity into the first run sequence. It's an activity that connects Studio to the database. In the process flow, we have two activities. The first one is a default UiPath activity that reads a spreadsheet, and the second one calls an addItems function. It's a function that we have created in MySQL, and it's used to add new items to our database table. This table acts in a similar way to the orchestrator queue. When the addItems function inserts a new row, the column QID receives a unique ID for that row, the column transaction ID receives a unique ID for that transaction, the column status receives the value of new, and the retry count column is initialized with the value of 0. There are also other columns that can be updated during the process. The column started date will indicate the time in which the transaction started to be processed, the column ended date will indicate the time in which the transaction stopped being processed, the column exception will indicate the type of exception the transaction had. In case of a business exception, the status of the transaction is updated to failed, and in case of an application exception, the status of the transaction is updated to retried, and a new copy of the transaction is added to the end of the table, with the value of the retry count column incremented in 1. Now we can take a look at what changed for the performer. First, we have to change the transaction item data type from queue item to data table, as all the data acquired from the database comes as a data table. In the initialization stage, we have once more added an activity into the first run sequence that establishes the connection between Studio and the database. In the getTransactionData flow, we have two activities. The first one calls the getItem function that we have created in MySQL. Basically, it's a function that verifies which transaction must be processed first based on the priority rules of the orchestrator queue, and then retrieves the QID for the line to be processed. The second activity uses the retrieved QID to get the data for the transaction to be processed. In the process flow, nothing has changed. We insert the values of the transaction into the UiDemo application. Here, we have two throw activities for demonstration purposes. One will throw a business exception if the caching value is bigger than 1000, and the other one will throw an application exception if the caching value is equal to 900. The last changes were made in the setTransaction status flow. Here, we have the three possible states: success, business, and system. Normally, we would have a queue activity, but we changed that for a database activity that calls a setStatus function that we have also created in MySQL, and it's used to update the status of the transaction. The same goes for the business exception and the system exception. Now, we can make a demonstration of how everything works. Again, we have the database table that is empty, so we must start by populating it using the dispatcher. Now I can update the table, and we can see that the table was populated and some of the fields were automatically updated, like QID, transaction ID, and some others. Now, we must use the performer to process each transaction. So let's do it. Now that the process is done running, we can update the table again. It's possible to see that the transactions were processed, and by the started date, it's possible to see that they really were processed in order of priority. One of the transactions was not processed. That is due to the fact that the postponed date is bigger than the current date, and this transaction will only be processed when the postponed date is smaller or equal to the current date. With that, we've reached the end of our demonstration. The dispatcher and the performer, as also the MySQL functions, will be available on our GitHub, that is in the description. Thank you for watching.